So let's continue in this video with our discussion about absolute value. We know in class today you talked about or reviewing what the concept of absolute value means. And we know absolute value is basically the measure of something from zero, the measurements of the distance of something from zero. So you had some fairly straightforward equations that you looked at in class. And now we're going to look at equations that get a little more complicated in terms of their structure. And you'll see some of those below. For example, the absolute value of x plus 12 is equal to 28, or the absolute value of 2x minus 3 is equal to 5. So what we want to do is actually go through a process, and as with everything with math, there's usually a process where we just kind of go through, and if there's a step that we need to follow, we do it before moving on. Or if that step doesn't have to be followed, we just bypass it and go on to the next step. So in today's notes, we're actually not going to worry about this first step of isolating. Okay, so there is going to be no isolating to do. We'll move on to that in our discussion in the next day or two. But what we will need to do is this step right here, where we're going to have to create two new equations where the absolute value bars are removed. Okay, so the bars are removed, the absolute value symbols are removed. And that's going to require us to acknowledge that whatever that expression is, it's either some defined distance to the right of zero, which means we will write an equation that's equal to the isolated solution. So I see that we're talking about being isolated, but we're talking about the solution already being isolated. And then we'll write a second equation acknowledging that the expression that we're solving for can be some defined distance to the left of zero. So we're going to solve for a second equation that's the opposite of that isolated solution. So just to give you a sense of what we're talking about, if we visualize this equation on a number line, well, here's our number line. We'll mark 0. We know that the absolute value of whatever being equal to 28 means that we're either 28 to the right, so a positive 28, or we're potentially 28 to the left, so we're at negative 28. So what is it that we're measuring the absolute value of? Well, what we're measuring is the absolute value of this expression. We're measuring that this expression, x plus 12, or actually for that matter, I don't even need the absolute value bars there. We're measuring that this expression, x plus 12, is either 28 to the left of 0, or that expression, x plus 12, is 28 to the right of 0. So visually, we're beginning to see why it is that we solve two different equations. So what we're going to do is actually branch off. We're going to write those two equations. We're going to say x plus 12, that expression we're finding the absolute value of, is either equal to negative 28, because it can be 28 spaces to the left of 0, or we're solving that expression x plus 12 is equal to 28 spaces to the right of 0. So we simply create two equations, one equal to the positive of this value, one equal to the negative of that value. And then we just go ahead and solve. So both of these equations are fairly straightforward. You can see that they're both one-step equations, and both require us to subtract 12 from both sides. And you notice as you begin to solve these two equations kind of simultaneously at the same time, whatever we're doing to one side to solve one equation, we can write that out as the steps we're going to do to both sides of the other equation. So when we're done, we can cancel out the 12s, and we get x equals, let's see, negative 28 minus 12 should give me negative 40. And I like to just use a comma to separate my solutions. And on the other side, we cancel out the 12s. X equals 28 minus 12. That's 16. And we should be all done. Okay, so what we saw is a visual of what's going on here. We had this absolute value expression, which says find the distance of this. Find the distance of this thing, this blah, as we'll call it, x plus 12. Find whatever x will be that will make it 28 from 0. either 28 spaces to the right of 0 or 28 spaces to the left of 0. So one equation, x plus 12 equals negative 28. The other equation, x plus 12 equals 28, and then just solve through. So if we were to do a quick check, and actually we'll just do the check over here quickly. Here's our original equation. Absolute value, x plus 12 equals 28. Let's see. If I do negative 28 plus 12 and take its absolute value, whoops, let's try that again. I don't know why I'm saying negative 12 plus 12, negative 28 plus 12. Oh, hold on a second. If I do, one more time, if I do negative 40 plus 12, finding the absolute value of that, I get the absolute value of negative 28, which is 28. So check. If I do my other solution, 16 plus 12, that I'm finding the absolute value of, that's saying find the absolute value of 28. And that is also 28. So check. So we have both solutions work. So we have check, and we're good to go. So our final solutions, two solutions, x equals negative 40 and x equals 16. And just by the way, what I like just for style, I like to always state my answers in increasing order. So the negative 40 will be the first solution that I see. So let's see if we can do this just following the process we established above without having to draw the number line. So I've got this expression. It's telling me it's equal to 5, this absolute value expression, which means that 2x minus 3 is equal to negative 5 because it's either 5 spaces to the left of 0 or 2x minus 3 is equal to positive 5 because it could also be 5 spaces to the right of 0. And now we can just move ahead with solving each of these as its own two-step equation. So if I'm going to add 3 to both sides here to isolate the equation or the variable expression, that's what I'm going to have to do on the other equation as well. So when I do that, my 3's cancel, and I will get 2x equals negative 2. Likewise here, when my 3's cancel, I will get 2x equals 8. We've isolated the variable. Notice we're just basically following simplify, isolate, solve, and then we'll move on. We'll divide everything by 2 to solve for x. Likewise, on the other equation, we'll have to do the same thing, divide everything by 2. Cancel. X equals, well, negative 2 divided by 2 is negative 1. Cancel my 2's. My other solution should be x equals 8 divided by 2 is 4. If I do a quick check, which you don't have to do in writing, but I'm just going to show you, my first solution that I will check is 2 times negative 1 minus 3, then I'm finding the absolute value of. Let's see, 2 times negative 1 is negative 2 minus 3, which I'm still finding the absolute value of. Negative 2 minus 3 is negative 5, which I'm still finding the absolute value of. And that gives me 5. So I know that answer is correct. And on the other side, I'm doing 2 times 4, subtract 3 from that, and then find the absolute value. Well, following order of operations, 2 times 4 is 8, which I'll have to subtract 3 from. 8 minus 3 is 5, which I'll continue to take the absolute value of, and that equals 5. That means our other solution is correct. So our final solutions, two solutions for this equation, x equals negative 1 and x equals 4. So again, just quickly reviewing the process. And for our purposes today, we'll start by taking the isolated absolute value expression, taking the isolated absolute value expression and breaking it apart and essentially saying it's equal to the negative of our answer of the equation, the positive of the answer of our equation, and then solving each of those two. So complete the practice that's on the Google form, and there'll be more practice for us to do in class tomorrow.